And this brings up what we were talking about yesterday. Notice how the curve has been drawn so that the sample points will be integers, right? Now, of course, you can't see that for certain. For all you know, maybe the height above 0 is supposed to be 6.1 or 5.9. But why not make life easier on ourselves and accept that it looks like it's going through the 6? So we talked about that yesterday, and that's what you did here. So that's good. So if it seems reasonable that it might be going through the integer, that's probably what the instructor expects. So it looks like you did that correctly. Okay, so we did a bunch of problems like that together. It's pretty sure you're going to see something like that on the test, and it looks like we've learned how to do that. So that Riemann sum, what's the purpose? What's the interpretation of that Riemann sum? What's the interpretation of that Riemann sum?
The Riemann sum is the area that's between the x-axis and the function between 2 and -2.
Okay, now let's talk about that a bit. That's not quite right. The Riemann sum is an approximation to the area between the axis and the curve, right? Because you can see that the Riemann sum is not including all of the area under the curve, and it's also including some area that isn't under the curve. So the approximation, the Riemann sum is an approximation to the area under the curve. How could we make it a better approximation?
By using more rectangles.
Yeah, here we only used 4 little rectangles. If we had used 1,000 rectangles, the approximation would be much better. What is the exact area under the curve? Well, the exact area under the curve, that's the definite integral. So the exact area under the curve is the definite integral. The Riemann sum is an approximation to the area. So the Riemann sum is an approximation to the definite integral. The more rectangles you use, the better the approximation is. How could we use Riemann sums to get the exact value? Well, we could use Riemann sums to get the exact value by taking the limit of the Riemann sums as the number of rectangles goes to infinity. If you use a very large number of rectangles, the approximation is very good, but it's still just an approximation. But if you take the limit as the number of rectangles goes to infinity, then that would give you the exact area underneath the curve. Okay, well, in any case, it looks like you would get full credit for parts A and B, so let's look at part C.
Okay.
Okay, so we were just talking about how the way to figure out the exact value of a definite integral is to take the limit of the Riemann sum as n goes to infinity, and that's what this problem is emphasizing. When you wrote the definite integral, you used the limits of integration. You didn't use the star or the I anymore, so those are all good things. I noticed that you wrote down below what delta x was and what xi was. That's probably not necessary in this problem, though, because that was something the question should have done. If you see what I'm saying, the question expressed this limit, was writing the integral as a limit, but it didn't tell you what the xi stood for, and it didn't tell you what the delta x stood for. So the question should have told us the delta x and the xi. So it's not necessary for us to write that in. You probably wouldn't lose credit for putting that in, except you have to be careful. You used a different symbol than the instructor did. What was the symbol your instructor used for the sample points?
For the sample points.
What was the symbol your instructor used?
Star.
Yeah.
Star.
So what you wrote down there doesn't quite make sense. You wrote what xi without a star meant. So it might be safer to leave that out. Well, I don't want to confuse you. If you have to write down the limit notation yourself, then you do need to include that information. But if you're writing the definite integral, then you don't need it. And maybe it's a little safer to leave it out in case you might have made a mistake in there. I doubt they would have taken off any credit for that. So it looks like you would have, as usual, I'm picking a couple nits. It looks like you would get full credit for that. So that looks like a good answer. That looks like a full credit answer on that problem. So that's something we were working on yesterday. That's good. One thing is just to make sure that you don't confuse those problems with some of the other problems. These videos are offered on a pay-what-you-like basis. you can pay for the use of the videos at my website. There's a link to my website in the annotation. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the annotation. Thank you.